Hi everyone, myself Dr. P. Ashok Babu, working as a President Head, AC Department. So in this video, I am going to discuss about some important definitions in transmission line part 2. So here what is OC transmission line, open circuited transmission line. So when a transmission line is terminated with infinity load impedance, that line is called the open circuit line. So what is the short circuited transmission line? So when a line is terminated with zero load impedance, that line is called the short circuited transmission line. So what is the use of impedance transformer? So it is also called quarter wave transformer. It is the impedance inverter which inverts the impedance low to high or high to low, or mainly it is used to convert the impedance from low to high or high to low. For example, 120 ohm load is to be matched to a 75 ohm line. Then the quarter wave transformer must have a Z0 of 95 ohms. So this is 95 ohms. Quarter wave transformer will match a 75 ohm load to a 120 ohm line, which is used to convert the suppose I want to transfer the information. When we are transferring the information, we need to increase or decrease the impedance. So here the impedance transformer can decrease the impedance value or can increase the impedance value. So what are the limits of reflection coefficient and VSWR? Limits. So here the limits of reflection coefficient are from -1 to 1, and the limits of VSWR are from 1 to infinity. So what is the stub matching? Stubs can be used to match the load impedance to the transmission line characteristic impedance. So here the stub is positioned in a distance from the load. So this distance is chosen so that at that particular point, the resistive part of the load impedance is made equal to the resistive part of the characteristic impedance by a impedance transformer action. Then the length of the stub is chosen so that it exactly cancels the reactive part of the presented impedance. So this is known as a stub matching. There are two types of stub matchings: single stub matching and double stub matching. So why double stub matching is preferred over a single stub matching? So a single stub matching is useful for fixed frequency only. So as frequency changes, the location of the single stub will have to be changed. Then other one is the single stub matching system is based on the measurement of voltage minimum. So hence for coaxial line, it is very difficult to get such voltage minimum without using slotted line section. So these are the two disadvantages of a single stub matching. So because of these two disadvantages, we have chosen a double stub matching for all practical applications. So what is the reflection? The phenomenon of setting up a reflected wave at the load due to improper termination or due to impedance irregularity in a line is known as reflection. So define the term insertion loss. So it is a ratio of current flowing in the load without insertion of the network to the current flowing in the load with insertion of the network. This is known as the insertion loss. So why OC stubs are open circuited stubs are preferred over the short circuit lines? So a short circuit stub is less prone to leakage of electromagnetic radiation. So and it is somewhat easier to realize. So on the other hand, an open circuited stub may be more practical for certain types of transmission lines. For example, microstrips are microstrips where one would have to drill the insulating substrate to short circuit the two conductors of the line. So because of all these practical applications, in all practical applications, we will use the open circuited stubs only than short circuit stubs. What are the two design parameters of a single stub? So here the two design parameters of a single stubs are the length of the stub LT and the spacing between the LS, the spacing between the load and stub. The spacing between the load and stub. So here it may be like this. So it is the length of the stub. The length of the stub is LT and it is the spacing between the load. Here it will connect the load. So here the spacing between the load and stub is known as the LS. So these are the two design parameters of a single stub. state the use of half wave line. So to find unknown impedances half wave lambda by 2 transmission line, we'll use the half wave line. So here when unknown load is connected to a half wave line, its values is known as input impedance of a half wave line. Then what is a matched transmission line? So when a transmission line is terminated with a characteristic impedance, that is line is called perfectly matched line. Define reflection coefficient. So the reflection coefficient is the ratio of reflected voltage to the incident current, incident voltage, or the ratio of reflected current to the incident current. We can define the reflection coefficient in two ways, in terms of current or in terms of voltage. It is denoted as K. What is the standing wave? Define VSWR. So if there is impedance mismatch on a line, reflected waves are formed on reflection waves are formed, and these are combined with incident waves form a standing wave. So voltage standing wave ratio is the ratio of maximum voltage to the minimum voltage in a standing wave, which can be denoted as S. S is equal to, we have V max to the V minimum, maximum voltage to the minimum voltage. So when a transmission line is considered as a series and parallel resonant circuit, when a transmission line is considered as series and parallel resonant circuit, a transmission line of lambda by 2 length, and it is short circuited at load end, then the line acts as a series resonant. That is, I repeat the definition: a transmission line of length lambda by 2 and it is short circuited at the load end, then the line acts as a series resonant. If line is open circuited at load end, it acts as a parallel resonant circuit. So what is the Smith chart? So it is a polar plot of the complex reflection coefficient. It is a polar plot of the complex reflection coefficient. So it is a transmission, it is a transformation of complex impedance into reflection coefficient plane. Reflection coefficient plane. Or it is used to find the different parameters. So define diffraction. So due to its high frequency signals bends around the edges of the object and tends to make the borders of its lighter. So this is known as a diffraction. So what are the applications of a Smith chart? So the Smith chart is used to measure the voltage standing wave ratio. It is used to measure the reflection coefficient. It is used to measure the input impedance of a transmission line. It is used to measure the admittance conversion. It is used for designing the single stub or double stub matching. So these are the applications of a Smith chart. So what is pseudo Brewster angle? So the magnitude reaches a minimum and the phase goes through minus 90 degrees at an angle. It is known as a pseudo Brewster angle. What is it? What is it? Same one. Define radiation intensity. So it is defined as the power radiated from an antenna per unit solid angle in a given direction is known as a radiation intensity. So define field pattern in linear scale. So here the field pattern in a linear scale typically represents a plot of magnitude of the electric or magnetic field as a function of the angular space. So define a power pattern in a linear scale. So the power pattern in a linear scale is typically represents a plot of the square of the magnitude of electric or magnetic fields as a function of the angular space. Define power pattern in dB. The power pattern in dB represents the magnitude of the electric or magnetic field in decibels as a function of the angular space. So what is the dissipation of a transmission line? So here, what is the dispersion? What is the dispersion of a transmission line? So here the dispersion means the propagation velocity of the propagation velocity on the line is not constant with frequency. So if the propagation velocity is not constant with respect to the frequency, then we can call it as a dispersion. So because of dispersion, the signal may receive at different time intervals or different frequency intervals. So what is the lossless transmission line? A transmission line is said to be lossless if the conductors of the line are perfect and the dielectric medium separating them is lossless. Define group velocity. The group velocity of a wave is a velocity with which the overall shape of the wave's amplitudes known as the modulation or envelope of the wave propagates through the space is known as a group velocity. Define characteristic impedance. The characteristic impedance is the impedance looking into, it is denoted as Z0, which is the impedance looking into an infinite length of line. Then define E-plane. It is defined as the electric field, the plane containing the electric field vector and the direction of the maximum radiation. Define H field. So it is defined as the plane containing the magnetic field vector and the direction of the maximum radiation. Define 1 radian. It is defined as a plane angle with its vertex at the center of a circle of radius r that is subtended by an arc whose length is r, which is known as a 1 radian. Define steradian. So it is defined as the solid angle with its vertex at the center of a sphere of radius r, which is known as a 1 steradian, which is used to measure the solid angle. Define polarization of the radiated wave. So it is defined as the property of an electromagnetic wave describing the time varying direction and relative magnitude of electric field vector. Define conduction dielectric efficiency. So it is defined as the ratio of power delivered to the radiation resistance RR to the power delivered to RR and RL. Then define refractive index. The refractive index of a ionosphere is defined as the ratio of phase velocity of a wave in vacuum to the velocity is known as a refractive index. Define first null beamwidth. It is an angular separation between the first nulls of the wave pattern or radiation pattern. Define the line parameters of a transmission line. So the performance of a transmission line mainly depends upon the parameters of the transmission line. So here the transmission line has mainly 4 parameters: resistance, inductance, capacitance and conductance. So these parameters are uniformly distributed along the transmission line. Hence it is also called distributed parameters of a transmission line. So define half power beamwidth. In a radio antenna pattern, the half power beamwidth is the angle between the half power, or it is a minus 3 dB frequency points of the main lobe when reference to the peak effective radiated power of a main lobe, which is known as a half power beamwidth. Define bandwidth. So a band of frequencies in a wavelength specified for the particular communication is known as a bandwidth. Define beam efficiency. It is defined as the ratio of power transmitted or received within cone angle to the power transmitted by the antenna. So it is repeat the definition. It is defined as the ratio of power transmitted within cone angle to the power transmitted by the antenna is known as a beam efficiency. So there are some definitions in transmission line 2. So okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.